afternoon, everyone. Thank you for staying through the last session of the day. And I have to personally apologize first to everyone for the switch up of schedules. It's due to a personal emergency. So, just to break the ice first, um, of course, we all know Python, and we pronounce it as Python. I'm going to judge you if you pronounce it as Python. Anybody here? We all got this clear, right? Now, for something more controversial, SQL. So, who pronounces it as SQL? Raise of hands. SQL. Okay. The other officially correct pronunciation is SQL. So, just a quick trivia: the official actually is SQL. Um, so it's by ANSI and ISO official. And SQL it was a coined pronunciation by the IBM when it was first started. And finally, I hope nobody pronounces it as squeal, or maybe anybody. Okay, I'm gonna judge you if you do. All right. So a brief background about me, just self-introduction. I have engineering background and I have a multifaceted experience in data and software. Uh, my first Python code, first Hello World, was in high school. It was still Python 2.7. And I did my first website, HTML, with bare HTML and CSS. And come college, I got introduced with other tooling, MATLAB, R, and did my full stack website using these frameworks, Bootstrap, Igniter, PHP, and also Django. Postgrad, it's more advanced usage of scientific tools or computational engineering. SciPy, NumPy, TensorFlow, Keras, PyTorch, all within the Python ecosystem. And early career, I started dealing with data. So that means Pandas data frames, data visualizations, and Jupyter notebooks. And also, of course, the good old Excel and VBA. So right now, while my career transitioned from an IC to a leadership focus role, the nature of the tooling and platform has shifted as well from individual-centric to a more team-centric tooling. Now I deal with platforms, cloud platforms, and also advocate for collective upskilling in our organization. So why this introduction? Because this sets the context for the talk, actually. Just to manage everyone's expectations, this will be less technical, rather. So I will focus on the divide Python SQL, and I will just give snippets on the technical side and specific examples for DuckDB. So let's just take a step back. If you think about it, in an organization, any data-driven business decision boils down to just one question: what's the solution to this problem? What is the key insight that you want to draw from this data? An analogy that I liken to this is identifying your summit. Do you want to go to the top of Mount Everest or Mount Pulag in the case of the Philippines? So, however, no matter how good you are, say you're a seasoned hiker, I think we know that it's better to do it in a group. So rather than doing it, climbing it all by yourself, it's alone at the top, right? So my insight, the answers shifted. Maybe before, maybe if I was in my early career, I would have answered this question. Oh, let me go straight to the top, me alone. But now it has shifted towards I will help you discover these insights yourself. So this analogy. It's perfect. One of my realizations, transitioning from a Python expert towards a more leadership role, because I think even the best principal engineers, they are responsible for guiding technical directions of an organization and mentoring the best teams rather than being the best of a particular framework, doing all advanced use cases. So about the summit, however, it's not always a summit, right? It's not always a big mountain that you have to climb. Sometimes it can be as simple as going to the level 3 of this building, just a flight of stairs. And in these cases, can't Excel, in the context of data, can't Excel solve this problem, right? Why do you have to do advanced Python, advanced data science tooling when Excel can do it? So this leads us to the ecosystem today. There's an overwhelming ecosystem of data tools right now, and that's just counting only Python integrations, but all across the ecosystem. But remember our first questions. What's the solution to this problem? What's the key insight that you want from this data? If you're gonna answer that question, what would you choose? Where you're gonna use Excel? You're gonna use Python? Are you gonna use SQL? So that's the problem right now. Things are moving fast. There are always new technologies, new libraries. Just months ago, if you know, there's a Python. You can now run Python code in your Excel. You know that. So, if you're in an organization, would you recommend that as a practice, right? Or how about some cloud platforms selling an end-to-end solution? Microsoft Fabric, for example, GCP. Then now you're facing a vendor lock-in issues. It's a question of sustainability and making sure that, alongside costs, of course. But what's stood the test of time? It's a really good foundation of Python and SQL. It doesn't matter the framework, it doesn't matter the tooling, it doesn't matter which library. A good foundation of Python and SQL will serve you well. So that old adage, all roads lead to Rome? Let's correct that. In this case, that Rome would be SQL. So I know this is a Python conference, right? So why not Python? So let me tell you why. If you're doing data, I'm sure you're familiar with this. Data frames, BI platforms, spreadsheets, ORMs, NoSQL even. If you're doing data analysis using Python pandas, can you easily transition to Excel? I don't think so. For one, I used to be good in Excel, but the last time I handled Excel workbooks was many years ago. I consider myself really good in pandas and Python. Unfortunately, it's now a struggle to go back directly at Excel. So, and it applies for many cases as well. If you learn a particular framework, let's say a particular BI platform, learn the syntax, maybe you say doing Power Query and Power BI. Is it easy to transition in other facets of the data ecosystem? Unfortunately, no. So the point of this slide is that in the end, everything across all these facets, SQL is ubiquitous, and it is foundational. In fact, even no SQL or no SQL, even MongoDB. If someone uses MongoDB, you can even use SQL syntax right now. So why? How did this come to happen? SQL is very old. Started in 1970s, many decades now, and it has been a standard across most databases. And in many industries, it has been a foundation of all their data systems. Portability. You can use it in BI tools, ORMs, data frame APIs, all have SQL syntax. Adaptability, these integrations. And for a quick historical context, the first relational database was published. It's a paper published by Edward Codd in 1970. And it served as a foundation of all our relational databases today. And the principles in that paper remain until today. So SQL has since then remained as a standard for structured data analysis. And on the other side of the coin, Python, we all know it, has grown over the past decades past decade has boomed. It's a general purpose of programming, and you can use it for all your data jobs. So different tool sets, it led to duplicated efforts. Some teams would prefer you doing your data workflow in Pandas. Some teams would prefer doing it in Excel, unfortunately. And some teams would use maybe SQL. So how can we move towards a better integration among Python and SQL? So we've seen it, ORMs, in the end, they're just abstractions of the database interactions that we do. And I think one of the questions earlier, it's about deciding whether to use raw SQL commands or the basic or repetitive commands that you do when you interact with a database in an application. So as always, the question is, it depends. There's no silver bullet. But as a general rule, complex SQL statements, you would rather do it in SQL rather than making the ORM fit in your specific use cases. And we've seen some developments as well on data-specific libraries. You can pip install these libraries, but unfortunately, they're tied to specific databases. And finally, pandas. We've all seen the proliferation of all these data frame libraries. Started with R, but then there's pandas, there's polars. It's a struggle when you're training a junior team. Oh, you just got to learn panda syntax. And then they see it's different compared to polar syntax, right? And the object-oriented, the OOP paradigm when it comes to Python and general programming, and with how pandas, in the end, it's always a struggle compared to for those who are shifting from more Excel focus or SQL backgrounds. And another concept that I want to sprinkle in here is the difference between an OLTP and an OLAP or OLAP database. OLTP or online transactional processing databases, and OLAP or online analytical processing databases. So the key difference here is that earlier I told you that 1970 was the first relational database, but it was it is specific for specific use cases and mostly for transactional process. Imagine POS or transactions that you do when in a web application. All those actions, the use cases for an OLTP is more appropriate rather than an OLAP database. So OLTP, I'm sure Postgres, MS SQL, and even DuckDB. Even the standard databases that you've seen around, those are OLTP. However, OLAP is more recent, and especially with the cloud data warehouses, they are primarily OLAP based. So BigQuery, Snowflake, these databases are OLAP. So what's the key use cases? OLAP is primarily used for analytical workflows. So when you're doing maybe historical analysis, maybe an aggregated data sets of a decade of data, if you do your query in a Postgres database and compare that performance against querying in a OLAP database such as BigQuery, it's a magnitudes of difference. So in the end, there's not necessarily a better database design between these two. It depends on your use cases. So now, after these concepts, let's go to DuckDB. Where does DuckDB fit in? And as a quick history about DuckDB, it was launched 2019 by authors Mark and Hannes. They're based in a research lab in Denmark. And it's an analytical SQL database, and it has 20 plus client languages. So I mean you can use DocDB if you learn, even if you're not a Pythonista, if you know R, Go, Rust, and all other languages. It's open source, MIT license, meaning you're free to use it for any case that you want. And finally, no external dependencies. It's as easy as doing a pip install DocDB in your Python environment. So I was talking about the OLTP and OLAP. And this diagram here, there's also another axis, the y-axis, in process versus in client-server databases. We all know Postgres. It's a client-server. It falls under client-server, and it's a transactional database. And ClickHouse, if you've heard of ClickHouse, but similarly Snowflake or Dremio, it's an analytical client-server. SQLite, who uses SQLite here? Right, okay. So I think we all know the advantages of using SQLite over Postgres. It's in process, meaning it lives within your application, right? And now, where can we place DocDB here in this diagram? It actually falls. It is an analytical in-process database. And before DocDB, there wasn't any database that fits those, that qualifies to fall under that quadrant. So imagine SQLite for those SQLite users. It's like SQLite, but you can use it for analytical workloads. So DocDB is based on Postgres syntax, meaning you don't have to relearn a new SQL dialect. It's Python data frame compatible. If you've done Pandas, Polars, Arrow, or any of those data frame libraries, there's a good chance DocDB has APIs on it. And one of the best features of DocDB is that it can process larger than memory data. It's an in-process database, so meaning, let's say you're just running it on a laptop, the data set doesn't fit your RAM, DocDB can process it. So even 1 terabytes of data, right? Your RAM is just 32 gig for a laptop. You have 1 terabytes of data to process as long as you have enough disk. DocDB can definitely work on that process. And finally, it's fast. We will look at the benchmarks later on. Oh yeah, here, it's in the next slide. So I was saying it's fast. H2O.ai launched these benchmarks based on the TPCH standard. So here's an example. You have 5 queries on 1 billion rows, and it's in a single node machine, 256 gig RAM and 128 CPUs. Here are the performances. So take note of this tooling and platform. If they're here, that means they're able to complete the queries. So DocDB is leading this. Basically, it took 24 seconds to do, on average, to do this, to process 1 billion rows. Compare it with ClickHouse, or a client-server database, Polars, and all other frameworks and libraries. Pandas here at the last. Right, so those were for basic aggregations. Now let's do advanced aggregations. So now the other frameworks and libraries are not appearing. That means they did not complete. So right now you're seeing, we eliminated a lot of libraries already, but DocDB still leads the race. Pandas is still good. Unfortunately, now it's starting to reach its limits. It took what, 4,506 seconds. That's around how many minutes? And for our another benchmark, is for joins. You know how join can be difficult for many databases. So in this case, this is a 1 billion row join, and DocDB comes second. Still good, especially for how difficult joins is. And here for a smaller scale, now we're only doing 100 million rows. It's a typical for data science workflow, 100 million rows, right? So many data scientists would use pandas for this. And in fact, many people I know just wait for their code to run for minutes, and it's been normalized. But now, if you have DuckDB in your tooling, the same query can be done in just 8 seconds. So that's how better DuckDB is in some cases. So just some caveat. Of course, these are benchmarks. Of course, we all have different use cases. So I just encourage you to just use DuckDB and figure out if it fits your use cases. So far, so good? Yeah. All right, so it's not just, DuckDB is not just about being fast, it also supports a very wide ecosystem. Operating system is not an issue. You can install it in any machine. So in fact, it's one of the best choice right now if you're doing embedded systems, so edge devices. And it can run anywhere. So like for example, it's just a pip install away, but you're not limited towards that. You can use it in R or any other environment. So, okay, I will not delve deeper in the technicals of DuckDB because there's documentation for that. So what I'm gonna go through in the following slides are my favorite use cases. So one of my favorite use case, although in practice I do not often do this, but I recommend this. With a DuckDB shell, imagine if you have an Excel file and you just want a quick analysis, or a CSV file. What would be your go-to? If you're doing pandas, load your Python environment, do your pandas thing. But I suggest another option. Well, this is more ad hoc. You don't have Python runtime rather. You can just launch a DuckDB shell. There's even a DuckDB shell in WASM, WebAssembly. You just go to the website, shell.duckdb.org. You can upload your file there and make some analysis of your CSV or Excel file. But I'm not going to provide an example because it's not Python syntax. Let's go to Python use cases for ad hoc data analysis. So here's an example. Let's say we create a Python pandas data frame and save it to a Parquet file, a large data set. This is 1 billion rows. And then we read it with pandas, just do some basic aggregation. Yeah, here, pandas didn't work. This is an actual notebook I run in my laptop. So 32 gigs of RAM, pandas could not do it. DuckDB could have did it, the same query, albeit not in Python syntax, it's in raw SQL, but it did it in 0.5 seconds. So, but hear me out. DuckDB, it has Python API. It has actually data frame-like syntax. So, if you still prefer your pandas syntax, data frame-like syntax, it will still perform the same. It will just be executing these SQL statements under the hood. Okay, so if you're doing ad hoc data analysis, you can explore DuckDB as your drop-in replacement to pandas. Another use case is virtual data sets. I'm sure we all have our cloud stores, Parquet files, but it doesn't have to be Parquet. It could be CSV, JSON. They're all there in your cloud storage. So typically, the only way for you to access that data is, well, use your cloud platform. If you're doing GCP, use BigQuery. If you're in Azure, use Azure's database, SQL. So with DuckDB, you can actually create views directly from your cloud storage. So here's an example. Let's say I have an S3 bucket, and I have a Parquet files in this daily records. I want to create a view, a filtered view, because I want to share this. Maybe a particular team wants a filtered data set. I don't want to share the whole data set, right? Because it's just there's no use case for that. It's just a simple select all. But a use case for this, for a visual data set, is make a filtered table. So this is a view. So consider here, it's a SQL statement. We created a view of filtered data of these daily records. And here's the filter conditions. So you might be asking, did this query execute? Actually, it didn't. It's not gonna execute just yet because it's a view. But we can, that view saves it into a file, shared data.db file, and now that view, you can actually share that reference to the shared data.db file, share to a colleague. Hey, I have a field, I have a view table. This is the path. You can just share it, and that colleague can directly access that view. So now you have your maybe junior analyst. I have this filter data set. They have this Python environment, a notebook. Just write this code. Now they have the filtered view. So the actual data transfer only happens here. But the view, it's a virtual table, all within the cloud storage. Another use case that I really like, if you're doing Streamlit or maybe similar data app frameworks, you know that you can just display or make the pandas transformations, aggregations within the app, right? So based on actual experience, when the complexity of the data app grows, the user experience becomes very bad. Like a typical aggregation just takes, 5 seconds? And if it's a data app, a web application, it's not usable. So, but with DuckDB, if you use DuckDB and its Python APIs, that performance greatly improves. So in this example, this is a simple pandas data frame. We got it maybe from a REST, from API, weather data. We read it using pandas and then displayed it in our web app and maybe do some complex aggregations. Now let's do the same with DuckDB in its Python API. We do some aggregations, and again, same flow. You just replace the aggregations. Now you have a much performant web application. So those three are just my favorite use cases, but there are a lot more. And just like last week, DuckDB published a new integration with Google Sheets. There's a lot more you can do with Google Sheets. And there are some of exciting things I can think of, just an example. So I really encourage everyone to just explore it and discover many use cases. So I just showed hypothetical use cases for you, but I'm gonna show some proof of this, but I wanna share some case study that we did, at least within my organization. So, as I said, my experience rooted from this talk, rooted from an actual experience. It stems from it. So for an actual case study, we were developing an internal data reporting application. It was, as I mentioned, it was pandas-based aggregations. It was maintained by the data team. And that's a challenge. If you're doing everything in pandas, it's all code. It's difficult to introduce other teams. But what's the web app about? It's a data application. It's a reporting application. Who knows the business logic? Who knows the specific complex, complex aggregations or data manipulations that would have to be done? It will almost always, it's the analyst team. So the challenges were maintainability and collaboration, and of course performance. And when we, of course, strategically sprinkled in DuckDB where it matters most, now we enabled our analysts to collaborate with us directly. They provide the domain knowledge, and while we work on maintaining the infrastructure. And of course, on the user side, the performance is greatly enhanced. Another use case, overall, that's for the data app. But overall, for business intelligence and dashboarding, same idea. We have your analyst team. How can we unify our workflows? SQL happens to be more approachable rather than force-feeding Python codes to our analyst teams. So in summary, just to wrap up this talk, we covered the idea of growing complexity of data ecosystem, Python and SQL integrations as the best of both worlds to address that complexity. We did some historical context and some key concepts, such as OLTP and OLAP. DuckDB, when to use, when not to use, please ask me after the Q&A. And lastly, we went over case studies. So do we still have time for Q&A?
We don't have time anymore.
Okay.
So thank you so much,
Thank you,
Mr.
everyone.
Sam Matuba, for that insightful talk. So unfortunately, unfortunately, we don't have any time for a Q&A, but you can maybe talk to Mr. Sam Matuba while we go to the main hall for the closing remarks. So